Far out in the cold, dark reaches of our solar system, a giant blue world spins in silence, hiding secrets that defy explanation. Neptune, the eighth planet from the Sun, is so distant that sunlight takes over 4 hours to reach its frozen surface. Yet despite being one of our closest planetary neighbors in cosmic terms, Neptune remains one of the most mysterious places we've ever glimpsed. What if I told you this distant blue giant harbors storms larger than Earth that vanish without a trace, that its winds scream through the atmosphere at speeds that would shred our strongest hurricanes to pieces? Or that its largest moon orbits backward, spewing mysterious geysers into space? Neptune doesn't just challenge our understanding of the solar system, it laughs in the face of it. Today, we're diving deep into the 25 most baffling, unexplained mysteries of Neptune. From vanishing dark spots to whispering radio waves, from ghostly rings to moons that shouldn't exist, each one of these enigmas will make you question what we really know about the outer solar system. So buckle up, because we're about to take a journey to the edge of the known cosmos, where the rules of physics seem to bend, and where every answer only leads to more questions. By the end of this video, you'll see Neptune not just as a blue dot in the distance, but as one of the strangest, most unpredictable worlds in our celestial neighborhood. Ready to unravel the mysteries? Let's begin. Now, let's turn our attention to Neptune's most famous mystery, the Great Dark Spot. Imagine a storm so massive it could swallow Earth whole, raging across Neptune's blue surface with winds tearing at over 1,000 miles per hour. When Voyager 2 flew by in 1989, it spotted this monstrous tempest, a swirling vortex as dark as ink, stretching nearly the width of our entire planet. Scientists compared it to Jupiter's Great Red Spot, but here's the twist: by the time the Hubble Space Telescope turned its gaze to Neptune just a few years later, the storm had vanished without a trace. So what happened to this colossal weather system? One theory suggests Neptune's turbulent atmosphere simply chewed it up and spat it out. Unlike Jupiter's stable storms, Neptune's weather is chaotic, with gases churning unpredictably. The Great Dark Spot might have been torn apart by opposing wind currents or swallowed by deeper atmospheric layers. Another possibility: our observations were just a snapshot in time. Storms on Neptune could be fleeting, appearing and disappearing faster than our telescopes can track them. But here's the real kicker: Neptune didn't stay spotless for long. New dark vortices have since appeared, only to fade again, leaving scientists scratching their heads. Why do these storms vanish while Jupiter's persist for centuries? Is Neptune's atmosphere fundamentally different, or are we missing a crucial piece of the puzzle? One thing's certain: the Great Dark Spot's disappearance reminds us just how little we understand about the violent, ever-changing world of Neptune. Now, shifting our gaze from Neptune's storms to its delicate rings, we uncover another cosmic puzzle. Unlike Saturn's bold, gleaming rings, Neptune's are faint, almost ghostly, and broken into uneven arcs. These rings are so dim that they weren't even discovered until the 1980s, when Voyager 2 close flyby revealed their elusive presence. So why are Neptune's rings so hard to spot? For starters, they're made of dark, dusty material that doesn't reflect much sunlight. Think charcoal smudges against a twilight sky. But the real mystery lies in their patchy structure. While most planetary rings form smooth, continuous loops, Neptune's are clumpy, with dense arcs separated by near-empty gaps. Scientists suspect these uneven clusters might be held together by the gravitational tug of nearby moons, like cosmic shepherds corralling the debris. What's even stranger is that these rings shouldn't last long. Normally, such sparse rings would either disperse or collapse inward within a few million years. Yet here they are, defying expectations. Could Neptune's rings be younger than we think, perhaps the remnants of a recent moon collision? Or do unseen forces like tiny, undiscovered moons keep them in place? The answers might rewrite what we know about how ring systems form and evolve. One thing's clear: Neptune's fragile rings are more than just cosmic leftovers. They're a window into the planet's turbulent past, hinting at violent encounters and gravitational dramas that shaped its history. And just like Neptune's vanishing storms, these faint rings remind us that even the quietest corners of our solar system hold secrets waiting to be unraveled. Now let's zoom in on one of Neptune's most baffling atmospheric quirks, a feature so fast and fleeting, it's earned the playful nickname the scooter. Picture this: a high-speed cloud darting around Neptune's atmosphere at breakneck speeds, outpacing the planet's own rotation. While Neptune takes about 16 hours to complete a single spin, this mysterious cloud laps it in just a few hours, racing like a cosmic speedster. So what's propelling the scooter? Scientists are stumped. On Earth, weather systems are driven by sunlight heating the atmosphere, but Neptune is so far from the sun that solar energy is barely a whisper. Yet here's this cloud defying all expectations. Some theories suggest it might be riding powerful jet streams, fueled by Neptune's internal heat. Remember, this planet radiates more energy than it receives from the sun. Others speculate it could be a towering plume of gas, erupting from deeper layers where pressures and temperatures create chaotic turbulence. What makes the scooter even stranger is its defiance of atmospheric models. Gas giants like Jupiter and Saturn have predictable wind patterns, but Neptune's weather is wild and unpredictable. The scooter's breakneck speed challenges our understanding of how energy moves through these distant atmospheres. Is it a freak anomaly or a clue to hidden forces shaping Neptune's skies? One thing's certain: the scooter isn't just a curiosity. It's a reminder of how much we still don't know about the outer solar system. Every time we think we've figured Neptune out, it throws us another curveball, proving that even the coldest, darkest reaches of space are alive with motion and mystery. Now, let's turn our attention to one of Neptune's most intriguing companions, its largest moon, Triton. Unlike most moons in our solar system, Triton has a rebellious streak. It orbits Neptune in the opposite direction of the planet's rotation, a phenomenon known as a retrograde orbit. This backward motion is a glaring clue that Triton didn't form alongside Neptune, but was likely captured by the planet's gravity later in its history. The leading theory suggests Triton was once a free-floating object in the Kuiper belt, the icy realm beyond Neptune. At some point, Neptune's immense gravitational pull snatched Triton out of its original path, forcing it into this unusual orbit. But capturing a moon as large as Triton, it's bigger than Pluto, would have been a violent event, likely disrupting Neptune's original moon system in the process. This could explain why many of Neptune's smaller moons have irregular, chaotic orbits today. What's even more fascinating is how Triton's capture has shaped its destiny. The gravitational tug-of-war between Neptune and its rebellious moon generates intense tidal forces, heating Triton's interior. This internal heat might be responsible for the moon's surprising geological activity, including those nitrogen geysers we'll explore later. Triton's retrograde orbit also means it's slowly spiraling inward, destined to one day either collide with Neptune or be torn apart by tidal forces, forming a spectacular ring system. Triton's backward journey is more than just a cosmic oddity. It's a window into the chaotic early days of our solar system, where gravitational encounters reshaped worlds. Neptune's grip on Triton reveals the raw power of gravity and the dramatic stories hidden in the orbits of distant moons. Now, let's zoom in on one of Triton's most jaw-dropping features, its active geysers. Picture this: plumes of nitrogen gas shooting miles into the thin atmosphere, creating a spectacle unlike anything else in the outer solar system. These aren't just frozen relics of the past. Triton's geysers are alive, erupting right now, defying expectations for a moon so far from the sun's warmth. So how does a distant, icy world like Triton manage such fiery activity? The answer lies beneath its frozen surface. Remember how Triton's retrograde orbit generates intense tidal forces? That gravitational tug of war with Neptune doesn't just shape its orbit, it heats Triton from the inside out. This internal warmth keeps parts of its subsurface volatile, allowing pockets of liquid nitrogen to form. When sunlight pierces Triton's thin ice crust, it vaporizes this trapped nitrogen, building pressure until, whoosh, the gas bursts through cracks, launching geysers high into the sky. But here's the real kicker. These geysers leave behind dark streaks on Triton's surface like cosmic graffiti. Scientists believe this material could be organic compounds or even carbon-rich dust, hinting at complex chemistry happening in the moon's hidden depths. It's a reminder that even in the solar system's freezer, geological drama unfolds. Triton's geysers don't just dazzle, they whisper secrets about how tidal forces and sunlight can team up to breathe life into the coldest corners of space. And speaking of surprises, this icy moon's activity might not be unique. If Triton, a captured Kuiper belt object, can stay geologically lively, what does that mean for other distant worlds? Could Pluto or Eris hide similar fireworks? Every eruption on Triton challenges our assumptions about where geological energy can thrive and where we might find it next. Now, let's shift our gaze from Triton's icy geysers to Neptune itself, where the winds tell a story of chaos and power unlike anything else in our solar system. Imagine storms so fierce they could swallow Earth whole, with winds screaming at speeds of over 1,300 miles per hour, nearly supersonic. That's faster than a jet fighter at full throttle, and it makes Neptune the undisputed champion of extreme weather in our cosmic neighborhood. But here's the puzzle. Neptune sits farther from the Sun than Uranus, yet its winds are nearly twice as violent. Why? The answer might lie deep within the planet's churning interior. Unlike Uranus, which seems oddly calm for a gas giant, Neptune radiates significant internal heat. This leftover energy from its formation, or perhaps ongoing gravitational compression, could be fueling its turbulent atmosphere like a cosmic engine. The heat rises, collides with colder layers, and sets off colossal wind currents that tear across the planet with mind-bending force. Another clue comes from Neptune's lack of a solid surface. With nothing to slow them down, these winds accelerate unchecked, whipping around the planet in vast, chaotic bands. Some storms, like the Great Dark Spot we discussed earlier, spin like monstrous hurricanes, while others vanish as suddenly as they appear. It's a reminder that distance from the Sun doesn't always dictate a planet's fury. Neptune's winds are a testament to the hidden forces at work in the outer solar system, where cold doesn't always mean quiet, and the rules of weather as we know them get rewritten. And if you think that's wild, just wait. These supersonic gusts might hold the key to understanding something even bigger: how gas giants across the universe evolve. After all, if Neptune can defy expectations, what other atmospheric surprises are lurking out there in the dark? Now, let's turn our attention to another head-scratcher in Neptune's playbook: its surprising warmth. You'd expect a planet so far from the Sun to be frigid, and it is, but here's the twist: Neptune actually gives off more heat than it absorbs from sunlight. That's right, this icy giant is somehow generating its own warmth, while its neighbor Uranus, which sits closer to the Sun, seems to be running on empty. So what's heating things up? One leading theory points to Neptune's turbulent birth. When the planet formed billions of years ago, the collisions and gravitational pull that shaped it may have left behind a reservoir of trapped energy. Think of it like a cosmic battery, slowly releasing heat over time. Another idea suggests that Neptune's interior is still settling, with heavier elements like rock and metal sinking toward the core. This gradual compression could generate friction, warming the planet from within like a slow-cooked meal. But why doesn't Uranus share this trait? After all, they're often called twins. The difference might come down to luck or chaos. Uranus could have experienced a colossal impact early in its life that disrupted its internal heat flow, leaving it thermally stunted. Neptune, on the other hand, may have avoided such a catastrophe, letting its natural furnace keep churning. Whatever the reason, this extra heat isn't just a curiosity. It's likely the engine behind Neptune's wild winds and storms. Without it, the planet might look as eerily calm as Uranus. Instead, Neptune defies expectations, proving that even in the coldest corners of the solar system, things can still get surprisingly hot under the collar. And that leaves us with one burning question. What other secrets is this distant world hiding beneath its blue veil? Now, shifting our gaze to another cosmic oddity, let's unravel the mystery of Neptune's magnetic field, a feature that defies the norms we're used to here on Earth. Unlike our planet's relatively tidy, north-south aligned magnetic field, Neptune's is wildly off-kilter, tilted at a staggering 47 degrees from its rotational axis. To make things even stranger, it's not even centered. Imagine a bar magnet shoved off to one side inside the planet, and you'll start to picture just how bizarre this setup really is. So what's causing this planetary wonkiness? Scientists suspect it all comes down to Neptune's internal soup. Deep beneath its blue clouds, the planet's magnetic field might be generated in a layer of electrically conductive slush, a mix of water, ammonia, and methane rather than in a solid core like Earth's. This slushy dynamo, churning unevenly, could be the culprit behind the field's dramatic tilt and offset. It's like trying to spin a wobbly top in a bucket of syrup. The result is anything but smooth. But this quirk isn't just a fun fact, it's a real headache for spacecraft. A misaligned magnetic field can play havoc with navigation, throwing off instruments and complicating missions. Just ask Voyager 2, which had to contend with Neptune's erratic field during its 1989 flyby. Future probes will need to account for this turbulence or risk getting lost in a magnetic maze. What's truly fascinating, though, is how this tilted field hints at Neptune's hidden depths. It suggests a planet with a dynamic, chaotic interior where nothing behaves quite as expected. And that leaves us wondering, if the magnetic field is this unpredictable, what other surprises are lurking beneath those swirling blue skies? Now, let's turn our attention to Neptune's ever-changing storms, a spectacle that keeps astronomers on their toes. While Jupiter's Great Red Spot has been raging for centuries, Neptune's storms come and go like fleeting cosmic performances. One moment, a massive dark vortex dominates the atmosphere, and the next, it vanishes without a trace. This unpredictability makes Neptune's weather unlike anything else in our solar system. So why is Neptune's atmosphere so restless? One theory points to the planet's extreme wind speeds, the fastest in the solar system, which can tear storms apart before they have a chance to stabilize. Another possibility lies in Neptune's internal heat. Unlike Uranus, its icy twin, Neptune radiates more energy than it receives from the Sun, creating turbulent conditions that fuel short-lived storms. Imagine a pot of water boiling violently. Neptune's atmosphere might be churning in a similar way, with heat from below stirring up chaos in the clouds above. Then there's the mystery of the storms themselves. Some, like the Great Dark Spot spotted by Voyager 2 in 1989, disappear within years, while others, like the smaller Wizard's Eye, linger longer. The difference might come down to size and depth. Larger storms could dig deeper into Neptune's atmosphere, tapping into more energy, while smaller ones fizzle out quickly. Or perhaps it's the planet's tilted magnetic field, which we just discussed, adding another layer of instability to the mix. Whatever the cause, Neptune's storms remind us how little we truly understand about this distant giant. Every observation peels back another layer of mystery, leaving us to wonder, what will we see next time we look? Now, shifting our gaze to another puzzling aspect of Neptune, let's tackle the mystery of its missing methane. Scientists have long known that Neptune's deep atmosphere is rich in methane, the gas responsible for its striking blue hue. Yet when they examine the upper layers, they find far less methane than expected, almost as if it's vanishing into thin air. So where does it go? One leading theory suggests chemical reactions are to blame. In Neptune's upper atmosphere, intense ultraviolet radiation from the sun could be breaking methane apart, transforming it into heavier hydrocarbons like ethane or acetylene. These compounds might then sink deeper, leaving the upper layers methane poor. Think of it like a cosmic alchemy lab where sunlight acts as the chemist, reshaping molecules before they drift away. Another possibility is atmospheric escape. Neptune's gravity is strong, but not strong enough to hold onto every molecule. Over billions of years, some methane may have leaked into space, especially if it was lifted high enough by storms or other atmospheric disturbances. It's a slow process, but given Neptune's age, even a tiny trickle could add up to a significant loss. Then there's the wild card. Could unknown weather patterns or seasonal changes be hiding methane elsewhere? Neptune's long, unpredictable seasons, each lasting decades, might temporarily trap methane in lower layers, making it seem scarce when it's just out of sight. Whatever the explanation, this methane mystery highlights how much we still don't understand about Neptune's dynamic atmosphere. Every answer we uncover seems to lead to another question, keeping astronomers endlessly fascinated by this distant blue enigma. Now let's turn our attention to a storm that seems to defy Neptune's usual atmospheric chaos, the so-called Wizard's Eye. Unlike the Great Dark Spot, which vanished without a trace, this smaller, eerie storm has clung to existence, earning its mystical nickname. What makes the Wizard's Eye so stubborn while other storms disappear in a cosmic blink? First, consider its size and structure. The Wizard's Eye is more compact than the Great Dark Spot, which may help it survive. Larger storms, like the Great Dark Spot, might dissipate because they're more vulnerable to disruptions in Neptune's supersonic winds. Think of it like a towering sandcastle versus a small, sturdy rock. The bigger the structure, the easier it is for the wind to tear it apart. Then there's location. The Wizard's Eye appears to sit in a relatively stable part of Neptune's atmosphere, where winds shear. The difference in wind speed at various altitudes is less extreme. This could act like a protective bubble, shielding the storm from the forces that dismantle others. Meanwhile, storms like the Great Dark Spot might form in more turbulent zones, doomed from the start. But perhaps the most intriguing clue lies beneath the clouds. Some scientists suspect long-lasting storms like the Wizard's Eye tap into deeper heat sources within Neptune's interior. If a storm draws energy from below, it could sustain itself far longer than one relying solely on atmospheric chaos. It's like comparing a candle to a bonfire. One flickers out quickly while the other burns for hours. Whatever the reason, the Wizard's Eye reminds us that Neptune's weather is full of contradictions. Some storms rage and fade, while others linger like cosmic ghosts, challenging everything we think we know about this distant, turbulent world. Now, shifting our gaze from Neptune's turbulent storms to its enigmatic moons, we encounter Nereid, a celestial oddball with a dance unlike any other. This irregular moon doesn't follow the neat, circular path you might expect. Instead, it traces a wildly eccentric orbit, swinging far out into space before looping back close to Neptune in a cosmic roller coaster ride. So, what could explain such a chaotic trajectory? One leading theory suggests Nereid wasn't always part of Neptune's family. Its lopsided orbit hints at a dramatic past. Perhaps it was a free-floating object from the Kuiper belt, snagged by Neptune's gravity in a fateful encounter. Imagine a traveler wandering too close to a planet's pull, forever bound to its new home but never quite settling into a tidy orbit. But there's another twist. Nereid's path is so extreme that some scientists suspect it bears scars from ancient collisions. A violent impact with another moon or passing object could have sent Nereid careening into its current erratic path. Alternatively, gravitational tugs from Neptune's other moons like the massive Triton might have yanked Nereids' orbit out of shape over time. What makes Nereid especially fascinating is how it defies expectations. Most moons, once captured, eventually settle into stable orbits, yet Nereid's stubborn irregularity suggests Neptune's gravitational grip isn't as orderly as we once thought. It's a reminder that even in the outer solar system, chaos leaves its mark, etched in the strange, looping path of a moon that refuses to conform. Turning our attention from Neptune's chaotic moons to its delicate rings, we find another puzzle: Neptune's so-called ghost rings. Unlike Saturn's bold, dazzling rings, Neptune's are faint and fragmented, almost like whispers of dust and ice clinging to the planet's orbit. These elusive rings are so dim that they weren't even discovered until Voyager 2 flew by in 1989, and even today they're a challenge to observe. What makes these rings truly bizarre is their uneven structure. Instead of forming smooth, continuous bands, they clump together in dense arcs like beads on a broken necklace. This defies everything we know about ring dynamics normally. The gravitational pull of nearby moons should spread these particles evenly over time. Yet Neptune's rings stubbornly cling to their clumpy formations, as if some unseen force is holding them in place. Scientists have a few theories about what's going on. One idea points to tiny shepherd moons, too small to detect, whose gravity might corral the ring material into arcs. Another suggests that resonance's gravitational tugs from larger moons like Galatea could create stable pockets where the ring particles gather, but neither explanation fully accounts for why these clumps persist without dispersing. The ghost rings offer a tantalizing glimpse into Neptune's hidden complexities. Their fragile, patchy nature hints at a delicate balance of forces: gravity, collisions, and maybe even electromagnetic effects, all playing out in the planet's faint, dusty halo. For now, they remain one of the solar system's quietest enigmas, a reminder that even the faintest features can hold the deepest mysteries. Now, let's peer into one of Neptune's most striking atmospheric mysteries: the dark vortices. These eerie, swirling holes in the planet's atmosphere are like cosmic fingerprints, revealing secrets about Neptune's turbulent weather. Unlike the bright, churning storms we see on Jupiter or Saturn, these vortices are deep, shadowy features, almost as if something has punched a hole through the planet's outer layers. So why are they so dark? Scientists believe these vortices are massive high-pressure systems where gases sink downward, leaving a gap in the upper cloud deck. Without the reflective methane clouds that usually blanket Neptune, sunlight gets absorbed instead of scattered, creating those inky black patches. But here's the twist: these vortices don't act like storms on other planets. While Jupiter's Great Red Spot has raged for centuries, Neptune's dark vortices come and go within just a few years, sometimes vanishing without a trace. What really sets them apart is their behavior. Many vortices drift slowly across Neptune's atmosphere, but some suddenly accelerate or change direction, defying predictions. Even stranger, they often sprout bright companion clouds, like fluffy white caps, that hover around their edges. These clouds might be methane crystals pushed upward by the vortex's winds, but no one knows for sure why they form or why some vortices have them while others don't. The dark vortices remind us that Neptune's atmosphere is a laboratory of the unexpected. Their fleeting, unpredictable nature challenges our understanding of planetary weather, proving that even in the outer solar system, the rules aren't always what they seem. Now, shifting our gaze to another fascinating feature of Neptune's atmosphere, let's talk about the bright companion clouds. These luminous patches often appear like glowing halos around the planet's dark vortices, creating a striking contrast against Neptune's deep blue backdrop. But what exactly are they, and why do they seem to cling to these mysterious storms? Scientists believe these bright clouds are made of methane ice crystals, lifted high into the atmosphere by the powerful winds swirling around the dark vortices. As gases rise and cool in the vortex's outer edges, methane condenses into tiny ice particles, scattering sunlight and creating those brilliant white caps. It's almost as if the vortices are wearing crowns of frozen gas. What's particularly intriguing is that not all dark vortices have these companion clouds. Some appear solo, while others are surrounded by multiple bright patches. This inconsistency suggests that Neptune's atmospheric conditions are far more complex than we once thought. The presence or absence of these clouds could hint at differences in wind speeds, temperature, or even the chemical makeup of the vortices themselves. Even more puzzling is how these clouds behave. Unlike the slow drift of the vortices, the companion clouds can shift rapidly, sometimes forming and dissipating within weeks. This dynamism gives us a rare glimpse into the churning machinery of Neptune's atmosphere, where hidden forces are constantly reshaping the planet's face. By studying these bright companions, researchers hope to unravel the secrets of Neptune's wind patterns and energy flow. They're not just decorative features, they're clues, helping us piece together the puzzle of how this distant giant manages to sustain such wild and unpredictable weather. Now let's turn our attention to something that might surprise you: Neptune's seasons. Yes, even this distant ice giant, bathed in faint sunlight, goes through seasonal changes just like Earth. But here's the twist: Neptune's seasons are nothing like ours. They're slower, stranger, and far more mysterious. Neptune's tilt is similar to Earth's at around 28 degrees, which means it has distinct seasonal cycles. But with an orbital period of roughly 165 Earth years, each season lasts for decades, about 40 years to be exact. Imagine waiting half a lifetime just for winter to turn to spring. These prolonged seasons have a dramatic impact on Neptune's weather. As sunlight shifts across the planet's hemispheres, it triggers massive storms, alters wind patterns, and even influences the brightness of its atmosphere. For example, when Neptune's southern hemisphere was in summer during the late 1990s, Hubble observed a significant increase in cloud activity, suggesting that the weak sunlight it receives still packs enough energy to stir up its turbulent skies. Studying these changes, though, is a monumental challenge. With such long seasons, we've only observed Neptune through a fraction of one full cycle since its discovery in 1846. Even Voyager 2's flyby in 1989 captured just a snapshot of its southern summer. By the time we gather enough data to understand a full seasonal shift, generations of scientists will have come and gone. What makes Neptune's seasons even more puzzling is how they interact with its internal heat. Unlike Earth, where sunlight drives most seasonal changes, Neptune's own internal energy plays a huge role. The planet radiates more heat than it gets from the sun, meaning its seasons are a bizarre dance between external sunlight and internal forces we still don't fully understand. So while Neptune's seasons might seem like a slow-motion version of Earth's, they're anything but simple. They're a reminder that even in the coldest, darkest reaches of our solar system, the universe finds ways to surprise us. And with every new observation, we get a little closer to unraveling the secrets of this enigmatic blue world. Now, let's shift our gaze to one of Neptune's most mesmerizing features, the so-called string of pearls. Picture this, a series of bright, perfectly spaced clouds stretching across Neptune's atmosphere like a celestial necklace. It's a sight so striking that astronomers couldn't resist giving it a poetic name. But what's really behind this stunning phenomenon? Unlike the chaotic storms and swirling vortices we've seen elsewhere on Neptune, the string of pearls stands out for its remarkable symmetry. These clouds aren't randomly scattered, they're evenly spaced, almost as if arranged by some unseen hand. Scientists believe this orderly pattern could be the result of atmospheric waves, similar to the way ripples form on a pond. On Neptune, these waves might be caused by the planet's extreme winds interacting with its complex weather systems, creating areas where clouds consistently form at regular intervals. Another possibility is that these bright clouds are linked to Neptune's internal heat. As warmth rises from deep within the planet, it could trigger cloud formation at specific altitudes, producing these luminous pearls. The spacing might even hint at hidden structures in Neptune's atmosphere, like stable layers or pressure zones that guide where clouds can and can't appear. What's truly fascinating is how long-lasting this feature seems to be. While many of Neptune's storms come and go within years, the string of pearls has been observed multiple times over decades, suggesting it's a stable, or at least recurring phenomenon. That durability makes it a rare window into the deeper workings of Neptune's atmosphere, offering clues about the forces that shape its ever-changing skies. Of course, without more data, the string of pearls remains a beautiful mystery. Is it a product of Neptune's fierce winds, its internal heat, or something we haven't even considered yet? For now, it serves as a dazzling reminder that even in the outer solar system, nature has a way of creating patterns that captivate and puzzle us in equal measure. Now, let's turn our attention to one of Neptune's most peculiar moons, Naiad. This tiny moon has an orbit so unusual it's been nicknamed the Horseshoe, and for good reason. Unlike most moons that follow a predictable circular or elliptical path around their planet, Naiad dances in a way that defies expectations. Imagine a horseshoe lying flat on a table. Naiad's orbit traces a similar shape relative to Neptune, swinging closer and then farther away in a rhythmic pattern. At one point, it might seem like it's catching up to another moon, only to slow down and fall behind, creating this looping motion. This bizarre behavior is caused by the delicate gravitational tug-of-war between Naiad, Neptune, and its neighboring moons. How does this even work? Think of it like two runners on a circular track. If one speeds up slightly, they'll eventually lap the other, but in space, gravity can create a push and pull effect that prevents the faster object from fully overtaking the slower one. Instead, they engage in a cosmic dance, swapping positions in a repeating cycle. In Naiad's case, its orbit is locked in this gravitational resonance, making it one of the few known examples of a horseshoe orbit in our solar system. What's even more intriguing is what this tells us about Neptune's moon system. Naiad's strange path suggests a history of gravitational chaos, perhaps collisions, close encounters, or even captures from the Kuiper belt that left their mark. It's a reminder that Neptune's moons aren't just passive spectators but active players in a dynamic gravitational ballet. Could Naiad's orbit change again in the future? Absolutely. Gravitational interactions are unpredictable over long timescales, and this little moon might one day break free from its horseshoe pattern. For now, though, it remains a fascinating clue to the turbulent past and ever-evolving present of Neptune's celestial neighborhood. Just when we think we've mapped out Neptune's celestial family, another enigma slips through the cracks, or in this case, vanishes from sight. Meet S/2004 Neptune's elusive disappearing moon. Discovered in 2013 by the Hubble Space Telescope, this tiny world is so faint and small, just 12 miles across, that spotting it feels like finding a single flickering candle in a pitch-black stadium. What makes this moon so hard to pin down? For starters, its dimness pushes the limits of even our most advanced telescopes. Unlike Neptune's brighter moons, S/2004 doesn't reflect much sunlight, and its orbit is tucked so close to the planet that Neptune's glare often drowns it out. Astronomers have only caught fleeting glimpses, leaving its exact path and properties shrouded in uncertainty. But here's the real head-scratcher. If something this small and stealthy slipped past us for so long, how many other hidden moons might be orbiting Neptune? The math suggests there could be dozens, maybe even hundreds, of undiscovered moonlets, each no larger than a city. Some might be remnants of ancient collisions, while others could be captured Kuiper belt objects drifting silently in the darkness. The challenge isn't just about technology. Neptune's chaotic gravitational environment, with its swirling storms and tangled moon dances, could be masking these faint objects, nudging them into orbits that defy prediction. Future missions like advanced space telescopes or even a dedicated Neptune orbiter might finally bring these shadowy moons into the light. Until then, S/2004 N1 serves as a humbling reminder. Even in our own cosmic backyard, the universe loves to keep a few secrets up its sleeve. Now, shifting our gaze to Neptune's turbulent skies, we encounter a rare and puzzling spectacle, the phenomenon of dual storms. Imagine two colossal tempests, each rivaling Earth in size, raging side by side across Neptune's azure expanse. This isn't just a cosmic oddity, it's a window into the planet's chaotic atmospheric ballet. The first documented case of dual storms emerged in the late 1980s, when Voyager 2 spotted two dark vortices swirling in Neptune's southern hemisphere. Decades later, Hubble witnessed a repeat performance, a pair of storms brewing simultaneously, defying expectations. On most planets, massive storms are solitary events like Jupiter's Great Red Spot. But Neptune, it seems to break the rules with eerie regularity. So, what's behind this twin storm phenomenon? One theory points to Neptune's supersonic winds, which shear and stretch storms into elongated shapes, possibly splitting single vortices into two. Another idea suggests these storms might be born from a deeper, cyclical process, a kind of atmospheric heartbeat where disturbances ripple outward, triggering mirrored turbulence. Yet the most tantalizing question remains, is this duality pure chance or a clue to Neptune's hidden weather patterns? Some scientists argue that the planet's internal heat, unevenly distributed, could create hotspots that spawn storms in pairs. Others speculate that Neptune's tilted magnetic field plays a role, channeling energy in ways we don't yet understand. What's clear is that these dual storms aren't just fleeting quirks. They're pieces of a larger puzzle. Each time they appear, they challenge our models of planetary atmospheres, proving Neptune's weather is as unpredictable as it is violent. And with every new observation, we're reminded, this blue giant still holds the playbook to its own mysteries. Now, let's turn our attention to another frosty enigma high above Neptune's swirling clouds, the mysterious layer of methane ice crystals that give the planet an almost glittering haze. Unlike the methane we're familiar with on Earth, which often takes the form of gas, Neptune's upper atmosphere hosts a delicate frost of frozen methane, painting its skies in an otherworldly shimmer. So how does this frost form in the first place? Despite Neptune's bone-chilling temperatures, which dip below -300 degrees Fahrenheit, methane shouldn't naturally freeze at the pressures found in its upper atmosphere. Yet somehow it does. Scientists believe that as methane gas rises from deeper layers, it encounters just the right combination of cold and thin air to crystallize into ice particles, creating this ethereal frost. It's like watching breath freeze on a winter morning, except on a planetary scale. But here's the real puzzle. Why doesn't this frost sink back down? Neptune's gravity is strong enough to pull most particles toward its core, yet the methane ice lingers high above, defying expectations. One leading theory suggests that Neptune's violent winds play a role, constantly lofting the crystals upward like a cosmic snow globe. Another idea points to chemical reactions. Perhaps the methane interacts with other compounds in the atmosphere, forming lightweight particles that stay suspended. What makes this frost even more intriguing is its role in Neptune's vivid blue hue. While methane absorbs red light, giving the planet its signature color, the ice crystals scatter sunlight in ways that enhance its brilliance. It's a delicate balance, one that could unravel if the frost were to suddenly vanish or thicken. As we piece together the secrets of this frosted methane, we're reminded that Neptune's atmosphere is a place of contradictions, where ice floats against gravity's pull, and where even the faintest shimmer holds clues to the planet's hidden workings. Now, shifting our gaze from Neptune's frosty atmosphere to its striking ring system, we encounter yet another cosmic oddity, the planet's tilted rings. Unlike Saturn's iconic, neatly aligned rings, Neptune's rings are noticeably askew, slanting at an angle relative to its equator. This peculiar tilt raises a fascinating question. How did these rings end up so crooked in the first place? One possibility lies in Neptune's own axial tilt. The planet leans at roughly 28 degrees, much like Earth's 23-degree tilt. This means Neptune experiences seasons, albeit over a much longer timescale. Some scientists suggest that gravitational interactions over billions of years could have gradually pulled the rings out of alignment, matching the planet's tilt. Imagine a spinning top wobbling slightly. The rings might have simply followed Neptune's lead, but there's another, more dramatic explanation: past collisions. Neptune's violent history could include colossal impacts with rogue objects like asteroids or even wayward moons. Such a collision might have knocked the rings off kilter, leaving them permanently tilted. Evidence for this theory comes from Neptune's moon system, where irregular orbits hint at a chaotic past. If a massive object struck Neptune with enough force, it could have disrupted the ring plane, sending debris into a new, slanted arrangement. What's especially puzzling is that Neptune's rings aren't just tilted, they're also clumpy and uneven, with some sections brighter and denser than others. This suggests that whatever disturbed them didn't do so evenly, leaving behind a patchwork of debris. Could these clumps be remnants of the very objects that caused the tilt, or do they point to an ongoing process like the gravitational tug of nearby moons? As we unravel the mystery of Neptune's tilted rings, we're reminded that even the smallest details, like the angle of a ring, can reveal volumes about a planet's history. Whether shaped by slow gravitational shifts or sudden cosmic violence, these rings are a testament to Neptune's dynamic and ever-changing nature. And with that, we're ready to dive into another enigma, one that involves Neptune's elusive smaller moons, or rather, the puzzling lack of them. Now, let's turn our attention to one of Neptune's most baffling lunar mysteries, the case of the missing small moons. Astronomers have long predicted that Neptune, like other gas giants, should be surrounded by a swarm of tiny moons, far more than the handful we've actually detected. So where are they? One compelling theory suggests these moons might have met a violent end. Neptune's chaotic gravitational environment, shaped by its massive size and the odd orbits of its larger moons, could have torn smaller moons apart. Collisions between these fragile bodies might have shattered them into dust or rubble, leaving behind only faint traces in Neptune's ring system. Imagine a cosmic demolition derby where only the toughest moons survive. Another possibility is that Neptune's gravity simply booted them out. Close encounters with Triton, Neptune's largest moon, or gravitational tugs from passing asteroids could have sent these small moons hurtling into deep space. This would explain why we don't see them today. They've been exiled from the Neptunian system entirely. But there's a third, more intriguing idea. Maybe we just haven't found them yet. Neptune is incredibly distant, and spotting tiny, dark moons against the blackness of space is no easy feat. Advances in telescope technology might one day reveal a hidden population of these elusive moons, lurking in the shadows of Neptune's orbit. Whatever the answer, the absence of these small moons tells a story of Neptune's turbulent past. Whether destroyed, ejected, or simply hiding, their disappearance adds another layer to the planet's enigmatic history. And as we ponder this lunar puzzle, we're reminded that sometimes what's missing can be just as revealing as what's there. Shifting our gaze to Neptune's stunning appearance, one mystery stands out. Why is this planet such a vivid, deep blue, even more striking than its neighbor Uranus? At first glance, you might assume both ice giants would look similar, but Neptune's richer hue has puzzled scientists for decades. The answer lies in the secrets hidden within its atmosphere. Methane plays a starring role in Neptune's color palette. This gas absorbs red light from the sun, leaving behind the blues we see reflected back into space. But here's the twist: Uranus also has methane, yet it appears paler and more muted. So why the difference? Scientists suspect Neptune's atmosphere churns with more active weather, stirring up methane and other hydrocarbons to greater heights, intensifying its blue glow. But methane alone might not tell the whole story. Some researchers believe unknown compounds could be at work, adding depth to Neptune's signature shade. Traces of hydrogen sulfide or even complex organic molecules might interact with sunlight in ways we don't yet understand, creating that mesmerizing cobalt effect. Then there's the puzzle of Neptune's seasonal changes. Unlike Uranus, which rolls on its side, Neptune's tilt is more moderate, yet its color seems to shift slightly over time. Could atmospheric chemistry or solar activity be tweaking its hue? Or is there another layer of mystery waiting to be uncovered? Neptune's blue isn't just a pretty face, it's a cosmic clue, hinting at the dynamic and unseen forces shaping this distant world. And as we unravel its secrets, we're reminded that even the simplest questions, like why a planet looks the way it does, can lead us down the rabbit hole of discovery. Now, let's tune into one of Neptune's most enigmatic signals, the so-called whispering radio waves. Unlike the loud, crackling bursts from Jupiter or the steady hum of Earth's magnetosphere, Neptune's emissions are faint, almost ghostly, earning them their poetic nickname. These whispers aren't just unusual, they're unlike anything else we've detected in the solar system, and they might hold clues to the planet's hidden workings. So what's behind these mysterious signals? The answer likely lies deep within Neptune's magnetosphere, the invisible bubble of charged particles controlled by the planet's magnetic field. But here's the catch: Neptune's magnetic field is a cosmic oddball. It's wildly off-center and tilted at a steep angle, which means the magnetosphere wobbles dramatically as the planet rotates. This chaotic dance could be twisting and stretching the magnetic field lines, generating those faint radio waves as charged particles spiral along them. Another possibility involves Neptune's interaction with the solar wind. As the supersonic stream of particles from the Sun slams into the magnetosphere, it might trigger subtle vibrations in the magnetic field, like plucking a string. But why these vibrations sound so quiet compared to other planets remains a puzzle. Some scientists speculate that Neptune's great distance from the Sun plays a role. With weaker solar wind pressure, the resulting radio emissions could be far more subdued. Then there's Triton, Neptune's rebellious moon. Its geysers spew nitrogen gas into space, some of which gets ionized and trapped in Neptune's magnetosphere. Could this influx of particles be modulating the radio whispers, adding another layer of complexity? Or is there something entirely different, a process we haven't even imagined yet behind these ethereal signals? One thing's certain: Neptune's whispers are more than just cosmic static. They're a faint but vital transmission from a world that refuses to be easily understood, reminding us that even in the silence of space, there are stories waiting to be heard. Stepping back to take in the bigger picture, Neptune emerges as a true cosmic enigma, a world where nearly every feature defies expectations. These 25 mysteries we've explored aren't just isolated quirks. Together, they reveal a planet that operates by its own rules, challenging our understanding of how gas giants behave. Take Neptune's wild winds, for example. While Jupiter's storms rage for centuries, Neptune's vanish in years. Uranus, its icy twin, sits similarly far from the Sun yet barely stirs, while Neptune's atmosphere churns with supersonic energy. Even their magnetic fields tell contrasting stories. Uranus's is off-kilter, but Neptune's is practically tumbling, as if the planet couldn't settle on a single direction. Then there's the matter of heat. Jupiter and Saturn glow with leftover warmth from their formation, but Neptune, smaller and more distant, somehow outshines them relative to the sunlight it receives. Uranus, by comparison, is oddly inert. Why such extremes? It's as if Neptune took the rulebook for gas giants and tossed it into those supersonic winds. Even among its moons, Neptune stands out. Triton's backward orbit and icy geysers have no parallel among the major moons of Jupiter or Saturn. And while all gas giants have rings, Neptune's faint, clumpy arcs seem almost ghostly next to Saturn's dazzling display. Yet perhaps the most telling detail is how little we still know. Missions like Voyager 2 gave us snapshots, but Neptune's mysteries demand closer study. Unlike Jupiter and Saturn, visited by multiple orbiters, this blue giant lingers in the shadows, its whispers hinting at secrets we've only begun to decode. In the end, Neptune doesn't just challenge our ideas, it expands them. Every oddity, from vanishing storms to whispering magnetospheres, reminds us that the solar system still holds wonders beyond our imagination. And that's what makes it not just a puzzle, but a gateway to discoveries we can't yet foresee. Now, let's turn our gaze to the future, because Neptune's mysteries won't solve themselves. While past missions like Voyager 2 gave us a fleeting glimpse, the next era of exploration could finally pull back the curtain on this blue enigma. Scientists are already dreaming up bold new ways to study Neptune, from advanced orbiters to cutting-edge telescopes. One exciting proposal is the Neptune Odyssey mission, a concept being developed by NASA. This orbiter would dive deep into Neptune's atmosphere, studying its violent winds, bizarre storms, and unexplained heat. Imagine getting up close data on those supersonic gusts, or finally unraveling why Neptune radiates so much energy. Odyssey could even deploy a probe to taste the planet's exotic air, analyzing its strange chemistry firsthand. Then there's the power of next-generation telescopes, like the James Webb Space Telescope's successors. These instruments could peer into Neptune's faint rings, track its fleeting storms, and even spy on Triton's geysers from afar. With sharper eyes, we might catch details Voyager 2 missed, like the birth of a new dark spot or the subtle dance of its ghostly ring arcs. But why focus on Neptune when other planets seem more accessible? The answer lies in its contradictions. This isn't just another gas giant, it's a laboratory for extremes. Understanding why Neptune's winds are the solar system's fastest, or how its tilted magnetic field stays stable, could rewrite textbooks on planetary science. Plus, its moons, especially Triton, offer clues about the Kuiper belt and the early solar system's chaos. The clock is ticking, though. Neptune's long orbit means its seasons stretch for decades, so if we want to study its full cycle, we can't wait forever. Every year without a mission is a missed chance to catch its storms in action or map its shifting clouds. So here's the takeaway: Neptune isn't just a curiosity. It's a puzzle begging to be solved, one that could redefine how we see planets near and far. The tools are within reach, we just need the will to use them. And when we do, this blue giant might finally spill its secrets. Now we want to hear from you. Out of all these mind-bending Neptune mysteries, which one keeps you up at night? Is it the vanishing great dark spot, the supersonic winds, or maybe those eerie radio whispers? Drop your pick in the comments below. We're genuinely curious. And if you've heard of any wild Neptune mysteries we didn't cover, let us know. Your thoughts could spark the next big space discussion. Don't forget to hit like if this cosmic deep dive blew your mind, and subscribe so you don't miss our next adventure into the universe's unsolved puzzles. The cosmos is full of secrets, and together we're just getting started uncovering them. As we wrap up this journey through Neptune's strangest enigmas, one thing becomes clear: this distant blue giant is far more mysterious than we ever imagined. From storms that vanish without a trace to moons that defy orbital logic, Neptune keeps throwing curveballs at scientists. Even with all our advanced telescopes and space probes, so many questions remain unanswered. Why does Neptune radiate more heat than it should? What's hiding in those faint, clumpy rings? And what exactly is causing those eerie radio whispers? Every discovery seems to lead to two new puzzles. It's humbling to realize that Neptune, a planet we've known about for over 150 years, still guards so many secrets. But that's the beauty of space exploration. The more we learn, the more we realize how much is left to uncover. So here's a question to leave you with. If Neptune's mysteries teach us anything, isn't it thrilling to imagine what other cosmic surprises are waiting in the dark just beyond our reach? The universe loves a good mystery, and Neptune might just be its greatest unsolved riddle. If this deep dive into the unknown left you as fascinated as we are, don't forget to like this video and subscribe for more cosmic adventures. The universe is full of stories, and we're just getting started telling them. Until next time, keep looking up. Who knows what secrets the next discovery might reveal?